These are the worked out solutions for the study guide for benchmark 3 for algebra. And what I would recommend doing is checking over the problems that you did and see if they're checking against the answers I get, and then also redo them, copy them again. So instead of actually having to recopy the work, I've actually provided the PDF file for this benchmark that you can just print off and then do the problems again, see if you get the right answers. So we'll start off with this first one. First question is going to ask us about knowing number properties. And I tell you which ones they are. They're commutative, associative, distributive, or inverse or identity properties. So looking at this one, this is a commutative property. Commutative property of addition. Now it's a commutative property of addition because notice that the 3 moved in front of the x over here. So we're moving the terms around. So that's the commutative property. Commute, the word there shows us that we are moving. Here we're distributing 4 times x, 4 times 2. That made the 4x minus 8. So that's the distributive property. And then over here you look at it, look at the order, 3, 2, 1, 3, 2, 1. So the order did not change, so it's not the commutative. So what changed? Well, it was the parentheses. Notice the parentheses are around the 2 and the 1 here. But over on the other side, they're around the 3 and the 2. So that is the associative property of addition because things are being added there. Here, 3 times 1 equals 3. Whenever you multiply 1 by a number, you always get the same number. You get the identical number. And so this is the identity property of multiplication. And then this one, negative 3 plus 3. These are inverses of one another. They are opposites, and they always equal 0. And that's a property. It's called the inverse property of addition. Look at this one, 5, 2, 1, 5, 1, 2. It almost looks like the associative property, but notice the numbers here, 2 and 1. And then it goes 1 and 2. That's the commutative property. The commutative property of multiplication. So that was kind of a tricky one there. It looked like the associative because of the parentheses, but notice what changes. It's the order of the numbers, so that's the commutative. Next problem here. This one, we are trying to find roots. And so when we're doing this, this 2 down here is the number of roots. And so we have 2 roots. So 2 numbers that multiply to make 4. And then I'm raising this to the first power. Over here, I have 4 numbers that multiply to make 16. And I'm raising that to the first power. And on this one, 8 numbers, actually 3 numbers that multiply to make 8, all raised to the first power. And so when I look at that, 2 numbers that make 4, that are exactly the same, that multiply to make 4, would be 2. 4 numbers that multiply to make 16 would be 2 as well. See, 2 times 2 times 2 times 2 makes 16. 3 numbers that multiply to make 8, well, that's 2 once more. Remember, these are all raised to the first power, but any number to the first power is that same exact number. Multiply those numbers and you end up with 8. Taking a look at the next one, same sort of thing. It's using exponent rules. So 10 to the first power. Anything to the first power is just that number, 10. Anything to the 0 power is just 1. So 10 times 1, not 0, but 1. So remember that one. That's an important one to remember. And then here we have the 3 numbers that multiply to make 27. And then we're raising that to the first power. So we go ahead and do some work there. 10 times by 1 is just 10. Numbers that multiply to make 27, that are all the same, 3 of them, would be 3. 3 to the first power is 3. You multiply those numbers, so you get 30. Another problem, very similar. 2 numbers that multiply to make 9, that are both the same, all raised to the first power. Then any number to the 0 power, again, that's just going to be 1. Any number to the first power is just the number itself. And here another fractional exponent. 4 numbers that multiply to make 81. And again, that's all raised to the first power, because that's what the power is right here. So we do some work there. We've got the 2 numbers that make 9 would be 3. 3 times 1 is going to be 3. And 3 times 3 will be 9. Then 4 numbers that make 81. Oh, it's another 3. So we multiply out all those 3's and the 1, you get 27. Now the next problem is just multiplying terms with variables, and we have different bases here. So remember, it's all being multiplied, so we can use the commutative property. When you don't see an exponent, the exponent's 1. So I'm going to bring all the a's together. 4 a's and 1 a. Here I have 6 b's and 9 b's. And then I just count up how many a's I have. I have 5 a's all being multiplied. Here I have 15 b's all being multiplied. And that is our answer. We can't go any further than that because we can't combine the a's and the b's. Next one's exactly the same type of problem, except here we have a dot and no dots between, but it means the same thing. Again, when you don't see an exponent, put 1 as the exponent, and then just count them up. You got 1x and 2x's. You got 3y's and another 3y's. It's good to move terms around like that. See what you got. X to the third, y to the sixth. Or you're just adding up those exponents when they are being multiplied. Oh, another problem very similar to that last one. Here we have 3 3's, and here we have 4 4's, but they're being multiplied by 3 to the 8th. So let's bring the 3 to the 8th next to the 3 to the third, the 4 to the 4th next to the 4. Remember, any number to just where you don't see the exponent is really just to the first power. So you count up how many 3's you have. You've got 11 3's. You're adding up those exponents when we're multiplying the common base. And here we're going to multiply 4, and we've got to the 5th power. And there is our answer. Next problem here, we've got x to the third, y all to the 3rd power. So put a 1 as that exponent, and then go ahead and multiply those exponents. That's what we're supposed to do there. Multiply the exponents when we have the exponent on the outside, because what it represents is 3 groups of x to the third y. So it's like x to the third y, x to the third y, x to the third y. So the faster way to do that is to multiply exponents. So when you do that, you get x to the 9th, y to the 3rd power. That would be our answer. Same thing here, but before you multiply, why don't you just count up how many 8's you've got? You got 5 8's, and then we're bringing that all to that 4th power. So here's where you're going to end up multiplying, because you got 4 groups of 8 to the 5th. And so that makes 8 to the 20th power. Next problem, just exponents this time. Just multiply those exponents. You end up with r to the 12th, s to the 6th power. Just multiply exponents when you get the exponent on the outside. Same thing here. Multiply the 10 over those two numbers. 10 groups of x squared y to the 3rd. So it makes x to the 20th, y to the 30th. Well, those are exponent rules. Similar problems to questions 2, 3, and 4. Let's take a look at the knowing opposites. And so no opposites and reciprocals. Opposites, remember, those are just dealing with sign. The sign's going to change. So it's just going to be negative and then xy over 2. The next one deals with reciprocals. So reciprocal means flip that fraction around, turn it upside down. So that xy is going to go on the bottom, 2 is going to go on top, and that would be your answer, 2 over xy. Well, the next one, again, opposites. Opposites, you just have signs. So negative 3 squared over y. If you wrote it that way, I'd be fine. If you wrote negative 9 over y, I'm fine with that too. But notice it just says take the opposite. It just says take the reciprocal. So that's what I'll do here. And so when I take the reciprocal, put the y on top, and the 3 squared goes on the bottom. Well, opposite of 4x, it's just going to end up being negative 4x. And the reciprocal of 4x, well, think about what the 4x is as a fraction, and it's easier to figure out. If you don't see it as a fraction, it's always over 1. Take its reciprocal, you get 1 over 4x. Well, those are similar problems to the first 5. We'll take a look at other parts to find other problems.